Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam October-November 2023, paper 41. Let's start. Question 1. A list of gases is shown. Answer the following question using the gases from the list. You can use each gas once, more than once, or not use it at all. First one, mention the name of the gas that causes acid rain. Of course, sulfur dioxide, because it's acidic oxide, it can dissolve in the rainwater to form acid, so the answer is sulfur dioxide. Second, the name of the gas that form alkaline solution when dissolved in water. We have ammonia. Ammonia dissolve in water to give ammonia solution or ammonium hydroxide, which is alkaline. So the answer is ammonia. An inert gas, it's a gas from noble gases, group 8 in the periodic table, so the answer is xenon. A gas which is product of photosynthesis. We know that plants use carbon dioxide and energy from the sun to produce glucose and oxygen, so oxygen is a product of photosynthesis. A gas that can form polymer. This gas is ethene. Ethene can form addition polymer by breaking the double bond and adding more ethene molecules. Finally, which gas is produced in the test of nitrate ions? Test for nitrate ion, we add sodium hydroxide, aluminium foil, and heat. Ammonia gas is produced and can be tested by damp red litmus paper. It will change to blue. Question 2. Boron and aluminum are group 3 elements. Boron has only two naturally isotopes, boron 10 and boron 11. Complete the table to show the number of protons, neutrons, electrons in one atom of boron 11. Boron 11 has 5 protons. Of course, 11 minus 5 will be 6, so it will have 6 neutrons. Because it's an atom, it's a neutral, so the number of electrons equal to the number of proton. So we have 5 protons, 5 electrons, and 6 neutrons. The relative atomic mass of boron to one decimal place is 10.8. Determine the relative abundance of the boron 10 present in boron. Give your answer as a percentage. Here we have the relative atomic mass for boron is 10.8. Okay. Boron has two isotopes, boron 10 and boron 11. How can we know that which isotope has a greater percentage than the other? The relative atomic mass is not exactly in the middle between 10 and 11. It is much closer to 11. That means boron 11 is present in a greater percentage than boron 10. What is the percentage of boron 11? We will imagine the distance between boron 10 and boron 11 as 10 parts. 8 parts for boron 11 and only 2 parts for boron 10 because the relative atomic mass is much closer to boron 11. That means we have 80% of boron 11 and only 20% of boron 10. So the question here is asked about the relative abundance or the relative percent of boron 11 in the sample, so it will be 20%. Question 2. Use the relative atomic mass for boron to calculate the number of atoms in 0.54 grams of boron. Give your answer to the standard form. We know that the relative atomic mass is the mass of 1 mole. So 1 mole of boron contains 10.8 grams. Here we have 0.54 grams. So we have to calculate how many moles in this mass. We will divide 0.54 by 10.8 to get the number of moles of boron in this mass, which is 0.05. This is the number of moles of boron. Then we know that 1 mole contains Avogadro's number of atoms. So 0.5 moles of boron will contain this number of atoms, 0.05 times Avogadro to get the number of atoms. So we multiply the number of moles by Avogadro to get the number of atoms in this number of moles. The number of atoms will be 3.01 times 10 to the power of 22. You have to give your answer in standard form. C. Aluminium is extracted from its purified ore as shown in figure 2.1. Name the ore of aluminium. Of course, it is bauxite. The electrolyte contains aluminium oxide and other substance. Name the other substance and explain why it is used. The other substance added to the bauxite is cryolite, and cryolite is added to decrease the melting point of aluminium oxide. Here, he wants only one reason, which is the most important reason to decrease the melting point of aluminium oxide. So decrease the temperature needed and also, of course, decrease the cost. Write the ionic half equation for the reaction at the cathode. The reaction at the cathode, of course, aluminium are positive ions, so it will be attracted to the cathode. Aluminium has a charge of 3+, so it will gain 3 electrons to convert to aluminium metal, where the molten aluminium can be collected at the cathode. Explain why the anode need frequent replacement. Here we have oxygen from aluminium oxide formed at the anode and react with the carbon anode. So carbon anode react with oxygen formed at the anode to form carbon dioxide. That means the anode is eaten away and the anode has to be replaced regularly or frequently. State 2 physical properties of aluminium that make it suitable for use in overhead electrical cable. Aluminium has low density, so it can be used in the overhead cable, and of course it's a good conductor of electricity. E. Explain the apparent underactivity of aluminium. Why aluminium seems to be unreactive when reacted with acid or with water. This is due to the presence of unreactive layer of aluminium oxide on the surface that protect aluminium and prevent the reaction. Question F. Aluminium react with fluorine to form aluminium fluoride, AlF3. This is an ionic compound, so we will write a simple equation for this reaction. Simple means chemical equation, and here the equation is for 2 marks, so we need to balance the equation. Aluminium react with fluorine. Remember that fluorine is fluorine gas. It's a diatomic, so the formula of fluorine is F2, and the formula of aluminium fluoride formed already given in the reaction is aluminium F3, aluminium fluoride. Then we have to balance by adding 2 in front of aluminium to balance the F2. Then we will have 6F, so we will have 3 in front of fluorine, then add another 2 in front of aluminium to balance the equation. Complete the figure to show the electronic configuration of aluminium ion and 1 fluoride ion. Aluminium has electronic configuration of 283, so it loses 3 electrons, so only it will have 2 electrons in the first shell and 8 electrons in the second shell. So we will draw another shell with 8 electrons, and after losing 3 electrons, aluminium will have +3 charge, and the fluorine atom has electronic configuration of 2,7. It will gain, each fluorine atom will gain 1 electron from aluminium, so it will have 2, 8. The first shell will have 2 electrons, and the second shell will have 7 electrons originally present from chlorine, which is represented by 7 dots, and 1 cross because this electron comes from aluminium. And of course, because it gained 1 electron, it will have 1 negative charge. Here we only draw 1 fluoride ion, so each fluoride ion will gain 1 electron. We have 3 fluoride ions, so the 3 electrons lost from aluminium are gained by 3 fluorine atoms, but we only draw 1, as mentioned in the question. Question 3. The order of reactivity can be determined by displacement reactions. A student investigates the reactivity of 4 metals by carrying out a series of experiments. Each of the metal, lead, manganese, silver, and zinc, are added separately to aqueous metal nitrate of other metals. Okay, here in the table, we will use each metal in this row with the 4 metal nitrates. We will go this way: lead with lead nitrate, with manganese nitrate, with silver nitrate, with zinc nitrate, and so on. We will make the same for the 4 column. First, lead. It can displace silver nitrate but cannot displace zinc. So we can know that lead is less reactive than zinc and more reactive than silver. Here for manganese, manganese displaces lead and displaces silver, but it cannot displace zinc. So zinc is more reactive than manganese and more reactive than lead. Of course, we know that zinc is more reactive than silver, and lead is also more reactive than silver because silver is below hydrogen in the reactivity series, but lead and manganese are above hydrogen in the reactivity series. So silver is the least reactive. It cannot displace manganese, cannot displace lead or zinc. So zinc is the most reactive, then followed by manganese, because manganese cannot displace zinc. And after that, manganese can displace lead, but lead cannot displace manganese. So lead is the third metal, and finally it's silver is the least reactive. Of course, zinc can displace all lead from lead nitrate, manganese from manganese nitrate, and silver from silver nitrate. So from the table, we can arrange the metal according to the most reactive, from the most reactive to the least reactive: zinc, manganese, lead, and silver. Here, we have to complete the table, putting check mark, for the displacement and cross mark for the no reaction, or the reaction where displacement reaction doesn't occur. The order of reactivity from the most reactive to the least reactive: zinc, manganese, lead, and silver. Suggest why the metal nitrates and not the metal sulfate of these 4 metals are used for preparing the aqueous solution. Of course, we're using nitrates because all nitrates are soluble. Write a simple equation for the reaction between zinc and silver nitrate. Here again, the equation is for 2 marks, so we have to balance the equation. Zinc react with silver nitrate, correct formula of silver nitrate. Then forming zinc nitrate, zinc has a charge of +2 and nitrate is -1. So the formula will be ZnNO3 2. And because zinc is more reactive than silver, so it will displace silver metal. And we have to balance the equation by adding 2 in front of silver nitrate, because we have 2 nitrates here, so we will add 2 here. Now we have 2 silver, so we will add 2 in front of silver.
Question B. The reactivity of group 7 elements can be investigated experimentally. A student bubbled chlorine gas into a test tube containing aqueous potassium bromide. Describe the color change seen in the test tube. Here we have the equation: chlorine plus potassium bromide to give potassium chloride plus bromine. At the beginning, in the test tube, we have potassium bromide. As we know that all group 1 salts, like potassium bromide, they are all soluble in water to give colorless solution. So the initial color in the test tube is colorless. And because chlorine is more reactive than bromine, so chlorine displaces bromine from potassium bromide. Bromine has an orange color, so bromine formed, we have an orange color in the test tube. The color change from colorless to orange. Complete the ionic equation for the reaction, including state symbols. The ionic equation is for 3 marks, so we will have 1 mark for the state symbols, 1 mark for the correct formula and correct balance of the correct formula and correct charges of the ions, and the 3rd mark will be for the balance. To write the ionic equation, first we have to remove the spectator ions, which are the ions that didn't take part in the reaction, ions that have the same charge and the same state symbol in the reactant and the product. The only spectator ion here is potassium. It has +1 charge here and plus charge. Also, it has the same state symbol, aqueous and aqueous. So potassium has to be removed. Then we will rewrite the equation. Cl2 is a gas. We have 2 bromide ion with a charge -1, which is aqueous. And the product formed bromine water, Br2, which is aqueous, and 2 chloride ion with a negative charge, which is also aqueous. The reactivity trend seen in group 7 applies to all the elements in group 7. Use the periodic table to identify group 7 element which cannot displace any other element in group 7. The element which cannot displace any other element is the least reactive element in group 7. As we know, the reactivity of group 7 decreases as we go down the group. So the least reactive is the last element in group 7. We have to refer the periodic table given in the same exam to check which one is the last element in group 7. We will find that tennessine is the last element in group 7, so it is the least reactive, which has a symbol of TS. Question 4. Aqueous hydrogen peroxide slowly forms water and oxygen at room temperature and pressure. This reaction is catalyzed by manganese oxide. As we can see, hydrogen peroxide decomposes to give water and oxygen in the presence of a catalyst, manganese oxide. State the test for oxygen. The test is glowing splint, and the observation, the splint relights. Here, the student investigates the rate of formation of oxygen gas in the presence of manganese oxide, and the volume of oxygen formed measured at regular time intervals. The results are plotted on the graph 4.1. State how the graph shows that the rate of reaction at T2 is lower than T1. As we can see, the graph at T2 has lower gradient, so that means it has a lower rate. So we have to describe from the shape of the graph. We can say that the graph has lower gradient at T2. Explain using the collision theory why the rate of reaction at T2 is lower than T1. T1 is at the beginning of the reaction, so at the beginning we have higher number of particles of hydrogen peroxide, so of course higher frequency of collision and higher rate. By time, the number of the reactant particle decreases, so less frequent collision, and this will decrease the rate. So T2 has a lower rate than T1. So here the answer will be at T2, we have lower concentration of hydrogen peroxide or lower number of particles because the number of the reactant particle decreases by time, so less frequent collision between the particles and decrease the rate of reaction. In the same figure, sketch the graph obtained when the experiment is repeated using aqueous hydrogen peroxide at higher temperature. All other conditions remain the same. So we will have the same volume and the same concentration of hydrogen peroxide using the same mass and surface area of the catalyst. All conditions are the same, except we will have higher temperature. Of course, the temperature, increasing the temperature will increase the rate of reaction, so we will have the graph with higher gradient at higher temperature. So we will draw, this is the graph represent the shape of the graph at higher temperature. Of course, it will have higher gradient above the original graph, but it will have the same volume of oxygen gas because we are using the same mass and the same volume and the same concentration of hydrogen peroxide. So finally we will have the same volume of oxygen, and the graph will be above the original graph and or level off at the same volume of oxygen. C. Manganese oxide is added to 20 centimeter cube aqueous hydrogen peroxide. The total volume gas produced 72 centimeter cube at room temperature and pressure. So we have 20 centimeter cube of aqueous hydrogen peroxide produce 72 centimeter cube oxygen. Calculate the concentration of aqueous hydrogen peroxide in gram per decimeter using the following steps. First, calculate the number of moles of oxygen produced. We have the volume of oxygen, so first we will convert it to decimeter. Then, to get the number of moles of oxygen, we will divide the volume by 24. This is the number of moles for gases. The volume divide 24, so the volume will be, the number of moles will be 0.003 moles of oxygen. Then, number of moles of hydrogen peroxide which reacts. As we can see, the ratio between the number of moles of hydrogen peroxide to the number of moles of oxygen is 2 to 1. So the number of moles of hydrogen peroxide is double the number of mole of oxygen, so we will multiply by 2. The number of moles of hydrogen peroxide will be 0.006 moles. Then, to have the concentration of aqueous hydrogen peroxide in mole per decimeter, the formula that we have, the number of moles equal to the volume times the concentration. The volume is 20 centimeter cube. So first we will convert it into decimeter by dividing by 1,000. Then we will get the concentration 0.06 divide the volume. We will flip the fraction to get the concentration, which is 0.3 mole per decimeter cube. Then we have to calculate the concentration of aqueous hydrogen peroxide in gram per decimeter. To convert the concentration from mole per decimeter into gram per decimeter, we will just multiply by the relative molecular mass. So we will calculate the MR for hydrogen peroxide, which is 2 for 2 hydrogens and 32 for 2 oxygen. The total will be 34. So we will multiply the concentration mole per decimeter, which is 0.3, by the MR, which is 34, to get the concentration 10.2 grams per decimeter cube. Suggest the identity of other metal oxide which can also catalyze this reaction. We can use any transition metal oxide like platinum oxide or copper oxide. Question 5. Methane reacts with the steam to produce hydrogen gas. The reaction takes place at 1000 degrees Celsius and 100 kilopascal pressure. As we can see, the delta H has a positive value, so the forward reaction is endothermic. First, the reaction is reversible and reaches equilibrium in a closed system. State the two features of equilibrium. Of course, at equilibrium, the rate of the forward reaction equal to the rate of the reverse or the backward reaction, and the concentration of the reactant and the product are constant. State and explain in terms of equilibrium what happened to the concentration of hydrogen when, first, the pressure increased. First, we have to calculate the number of moles on each side. On the left side, we have 2 moles, and on the right side, we have 4 moles. So if we increase the pressure, the equilibrium position will be shifted to the less number of moles, which is, of course, the backward or the left side. So the volume of hydrogen will decrease. So here we have to answer the concentration of hydrogen will decrease because the position of equilibrium will be shifted left or backward because it has fewer number of moles. What happened to the equilibrium position when the temperature is increased? As we said from the beginning, the forward reaction is endothermic. So increasing the temperature will shift the equilibrium position to the right because the forward is endo, and the concentration, of course, of hydrogen gas will increase because the equilibrium position shift toward right or toward forward side because the forward reaction is endothermic. When a catalyst is added, of course, catalyst increase the rate of reaction but has no effect or no change in the yield of the product. So here, of course, the concentration of the hydrogen produced will not change because the catalyst don't affect the position of equilibrium. C. Methane is a greenhouse gas which contribute in a global warming. Name a greenhouse gas found in clean dry air. Here in clean dry air we also have carbon dioxide, which is greenhouse gas. Explain in terms of thermal energy how the greenhouse gas cause global warming. The greenhouse gas has an effect of increasing the temperature of the Earth's surface, and that causes global warming. First, the Earth's surface absorbs energy from the sun and reflected back to the atmosphere. But the greenhouse gas absorbs the thermal energy from the Earth's surface and reduce the thermal energy loss by reflecting this energy to the atmosphere. So the result is increase in the atmospheric temperature. Question 6. Ethanol is manufactured by 2 methods. Method 1, fermentation of aqueous glucose, and method 2 is catalytic addition of steam to alkene. Method 1 takes place at room temperature and pressure. State 2 other conditions needed in method 1. Method 1 is fermentation of glucose, so we need the presence of yeast because yeast contain the enzymes which catalyze the reaction. And of course, we need anaerobic condition for the yeast, so we need absence of oxygen, or we can write anaerobic condition at a temperature like 30 to 37 because this is the optimum temperature for the enzymes. Typical temperature and pressure used for method 2, which is the catalytic addition of steam. The temperature is 300 and the atmospheric pressure is 60 atmospheric pressure, or we can convert it into 6,000 kilopascal. To convert atmospheric pressure to kilopascal, we have to multiply by 100, so it is 6,000 kilopascal. Name the alkene used in method 2. Of course, we're preparing ethanol, so the alkene is ethene. State why the reaction in method 2 is referred as addition reaction. The word addition reaction means only one product is formed. So when he even asks you about the addition reaction, the answer will be because only one product is formed, because this is the meaning of addition reaction. The catalyst in method 2 is phosphoric acid. Dilute phosphoric acid is a weak acid which contain phosphate ions. State what is meant by the term acid. Acid is a proton donor, and what is state the meaning of the weak in the term weak acid. Weak acid means it is only partially dissociate. Determine the oxidation number of phosphorus in the phosphate ion. Here we have the phosphate ion has a total charge of -3. That means the oxidation number of phosphorus plus the oxidation number of the 4 oxygen will have a total value of -3. So we will have the oxidation number of phosphorus plus 4 oxygen. That means 4 times -2 because the oxidation of oxygen is -2. That means phosphorus plus -8 equal to -3. So the oxidation state of phosphorus will be +5. Question D. Give one advantage of each method of production of ethanol. Of course, method 1, which is fermentation, we can write any advantage, like it's cheap method, and we can also write because it uses renewable resources. Method 2 produces pure ethanol, and it is fast and continuous method. E. Ethanol can be converted into ethanoic acid by reacting it with acidified oxidizing agent. Name the acidified oxidizing agent. It is potassium manganate. State in the term redox what type of reagent ethanol is this, and of course oxygen will be the reducing agent because potassium manganate is the oxidizing agent. Ethanoic acid react with calcium to form a salt and one other product. Name the salt formed when ethanoic acid react with calcium. Ethanoic acid, like any acid, react with metal to produce salt and hydrogen gas. So the salt formed here is calcium ethanoate, as we can see here in the equation. Write the formula of the salt. We have the ethanoate ion, which is CH3COO, which has a negative charge, and calcium, which has +2 charge. So we will exchange the charges. We will have 2 for ethanoate ion and 1 calcium ion. So this is the formula of calcium ethanoate. Identify the other product formed. Of course, it's hydrogen gas. Like a typical reaction of metal with acid, it produces salt and hydrogen gas. Here we come to the end of our exam. Like the video and subscribe to the channel to receive all the updates. Comment down below if you have any question. Thank you for watching. Wish you all best of luck.